Okay, we'll get it started. I don't want to take too much of your time. I know everyone is quite busy, so thank you everyone for joining. This is our part 2 of our 3-part webinar series on the sealing out of the box. So it's a way of talking about gasket design and looking at the different components of gasket design. My colleagues are on here, so we have Sean from Newmarket. We have Sten and Veronica from Belgium that are here, and they'll be looking and monitoring the Q&A, the questions at the bottom. So feel free to chat at the bottom. So to ask questions, you can ask questions at any time. My colleagues will help me out and kind of wave me down, saying, "Hey, there's a question," and we'll be more than happy to answer the question. We'll go through it. It's not going to be a long one today. I think maximum maybe about half an hour. We're going to go through the different ways of fabricating a finished gasket. There's 2 videos we're going to watch, and we'll go from there. So let's just get it going. I'm going to start my presentation, and I will share my screen. My colleagues can help me out and just let me know if you see my screen.
Yes.
Do? Awesome. Okay. Just gonna minimize that. All right. So the benefits of gasket fabrication. So again, it's part of our sealing out of the box, part of our webinar series. So it's a 3-part webinar series that we are hosting. And again, looking at gasket fabrication, looking at reducing costs and adding a value, just a bit, stepping it up a bit from just receiving either an extrusion or rolls of extrusion or sheet stock. How can we go to the next step? How can companies design or help to go to the next step of getting a finished gasket for their production line or their application? So we'll be looking at different cutting, splicing, and lamination today. We'll dig down deeper on those 3. And we'll also take a look at maybe other services that we can potentially look at to help reduce the cost, reduce or increase efficiencies in your production line. So gasket fabrication services, we'll be taking a look at bonded and spliced gasket. What do those terminologies mean? There's also cut length, so specific length, cut to size extrusions that you can get. So instead of having a worker on the line unroll, measure, and cut, that's something that you can easily get from suppliers to get cut lengths delivered directly to you. So all your production line workers all have to do is just basically pick up the profile and install directly onto your application without taking the time of cutting it, potentially wasting material if the cut's not done properly, or you just missed, or you missed on the measurement, or whatever the case is. So cut lengths is a way of speeding up your production as well. Kitting is another form of fabrication services. How can I get everything in one box instead of taking the time to go pick individual pieces? Again, reducing the time, increasing efficiencies. So how can we get kitting done? Special packaging as well. We've had requests of 1 gasket per box per bag, depending on what application it is and where it goes. And there's also UV part marking as well. Great help. Again, production line, if you take a look at production line, is, you can mark it with your own part number, you can mark it with what gets installed first. So depending on the different applications or different ways you conceive or you're planning on improving your efficiencies, we can help communicate that directly on our part. So we're going to get started with 2 videos. The videos that I'll showcase is a video of, we'll start off with cutting. So what we've seen a lot of is, and I'm just going to stop sharing the presentation. I'll just pop up a video here. So in our experience of what we've been seeing a lot of is customers that are cutting sheet stock, either with a utility knife or an X-Acto knife or scissors to create the shape and form that they need. So they'll trace out the form and with a template, and then they'll go out and start cutting it by hand. Most often than not, you actually get skilled workers, welders, people that take care of the electrical harnesses on vehicles or applications that are actually out and cutting this. This video was shot. This is our colleague Sean that took the part that you see on the table over here. He traced it out, and he's attempting. Sean, can you just explain the thickness of this material so that everyone knows roughly?
Yeah, it's a 1/16 thick floor matting material. It doesn't match the actual gasket. The actual gasket's much thicker. It's about a 1/4 inch thick on the actual gasket, just to cut. Otherwise, I couldn't cut a 1/4 inch with scissors. So we've WATERJET cut the other part, and it just demonstrates my lack of cutting abilities, but how the actual gasket comes out. Hope the video will detail it in more.
So you're looking at almost 2 millimeter thick material that Sean's attempting to cut with scissors. So I'm just going to go ahead and play. And what we did is we time-stamped it just to showcase. And I promise you, Sean did not slow his cutting down on purpose to sell the other component of it, or saying, you know, it's just, this is what we actually see when we go and visit customers on the production line, and we see these types of operations being done. So we're just going to play the video. So already I'll ask Sean a question as I'm watching him cut. Sean, I noticed that are you supposed to be cutting on the outside of that trace line or on the inside of that trace line?
It was pretty much on the line, sort of, as close as I could try and get it. The cornering is difficult because it is a rounded corner, and it's yeah, it's not an easy cut to corner on it, unfortunately.
So the reason why I asked that question for, now there you go, I'll just stop it. There you go, 41 seconds to cut that part out. As you can see, it's about the size of his hand. It's not a big part to cut out. And the reason why I mentioned the lines where you're supposed to cut it on, looking at tolerances, which is really important when you're making a part like this. Would this be considered out of tolerance or not? What is it, inside, outside? So it's a lot of these types of questions that we usually end up asking or help at consulting on when we see these types of applications being done on production lines. So that's 41 seconds to cut one part. And Sean, no holes on that part, correct?
No.
Okay. So our other video that we have is with our WATERJET machine. The same part, we've time-stamped it again, and I'll just push play. So it starts off by cutting the holes and goes out now and cuts the whole part. So in half the time, you've actually got a completed part in tolerance, proper dimensions on that. So again, cutting, very important part of gasket fabrication. Questions that we often ask some of our customers is, you know, do you keep that internal or do you subcontract that out? You know, the advantage of, you know, doing it on an, so I'm just going to play from wherever we were at. This was the, there we go. So those are the two videos that we watched. So why WATERJET cutting is better than manual cutting, okay? As you can see, reduced material handling time. So it's, you're just taking a sheet, putting it onto the bed of the WATERJET, and it does the cutting for you. The employee doesn't have to stand there cutting. You're reducing your risk of potential injuries. The amount of times, you know, we see people cutting with an X-Acto knife on a template, and the dangers of that, if a slip or whatever it is, could end up being an injury on the line. So very important to keep that into consideration when it's coming to the actual labor components of WATERJET. Okay, and um, looking at what Sean cut with the scissors, would that have passed inspection down the line in terms of that have been in tolerance or not? So maybe out of 10, will we have gotten 10 on 10? The advantage of the CNC cutter or the WATERJET cutting machine is that the part is basically copied and pasted and just cut. It's a rinse and repeat operation. Where Sean, correct me if I'm wrong, I'm pretty sure if you can cut 10 parts, I don't believe you'll get one that will be similar to the other. You'll probably get 10 different parts cut if you do it by hand.
No, I did try and keep that one as quite as tight as I could to tolerances, and it still was out.
So the other important part here is regarding the material. There's a cost to materials, right? It's the raw material, and we try to reduce material waste. That's a big part in production, is how can we reduce material waste and how can you yield the most amount of parts on a given sheet, for example. So we do a lot of nesting we use like a Mastercam program that can actually take your components. So if you have even more than one piece on your kit, the software will calculate what's the best way of piecing these parts on a given size sheet to reduce the amount of waste possible, so that we can actually get very close to your cuts to each part with the WATERJET cut versus scissors or an X-Acto knife, where you have to maybe leave more space in between the parts, therefore increasing your material waste. These are all hidden costs that you do not see right away, but down the line, it does add up. Okay, and like the last line, cutting edges are not aren't rough or beveled, which is important depending again where the gasket is going and how tight the design of the gasket is or the part is fabricated. It could even be an installation part. If the edges are rough, does it increase your installation time? Does it increase your gasket fabrication time? Because you might have to sand some parts down or do some touch-ups to make sure that it's smooth enough to install onto your application. So very important part of that. The efficiency and the productivity. So I think one of the biggest things, if you compare it to die cutting, we get compared a lot to die cutting. So yes, die cutting, large volumes, absolutely yes. Go ahead and go do die cutting. There is going to be a tooling charge for die cuts. However, the volumes, if you have high volumes, and I'm talking thousands, not tens of thousands, it's worth going towards die cutting parts. If you have a couple of hundred parts, die cuts, again, depending on what you're cutting, some toolings are not expensive whatsoever, and some toolings are on die cutting, could be quite costly depending again what you're cutting. But you have to take that cost into consideration. Advantage of WATERJET cutting is that there is no tooling. So it's for rapid prototyping, or if you need something that you have to go to, you got to go into market really quick. Basically, we go from a CAD design and go straight to the WATERJET machine to get that cut, and you got a finished part almost right away. So the lead times is less, again, depending what it is that you're cutting and how quickly you need to cut. The other advantages with WATERJET cutting versus a die cutting is also that 90-degree corner. Die cutting have a hard time coming up with that finished sharp edge to it. Most of the time the corners are rounded slightly, but there are a bit of a rounded corner to it. So if you need sharp edges or detailed cuts to be done, WATERJET cutting is the best way to go. So like I mentioned before, the quality and consistency, it's the same cut over and over again. The tooling does not have to be stopped or sharpened to maintain that quality over time. Like it says with their CAD files go directly to, it's for digital manufacturing. So from CAD right away to the WATERJET machine, and you can get your cuts done right away. It's the machine that does the work, not the employee. So we can have different people on the machine. It doesn't matter. It's the machine that does the cut. So you'll know that if your drawing is good and properly detailed, your output will be on spot on with almost none or no errors on that part whatsoever. So another part is that with the when it comes to bonding gaskets together, WATERJET cut parts, it creates a smooth surface. So to bond a gasket together, it's absolutely key and reduces bonding time when we create our gaskets. All right, so reduces labor costs, reduces material waste, increases efficiency and productivity, and improves quality and consistency. That's the advantage of the WATERJET cutting. We'll move on to gasket bonding. Now, what this picture showcases and is we call this our super gasket. It's a sample that you can ask one of our representatives to send to you, and it comes with a detailed document that kind of showcases the different ways of bonding gaskets together. It also showcases different tapes or different methods on that. And what I have here is I'll just stop sharing my screen and I'll just I'll stop sharing. So I have a sample of, again, with the virtual background, there we go. So I have a sample of it in my hands right now. So this is something, again, that you can get from one of our representatives. It showcases the different ways, again, of bonding the corners. And in the document, we'll give you a bit more detail on that, or you can ask one of our reps to give you a crash course on this. But we'll go over the ways of bonding on the presentation. So this is something we created so that it gives engineers or anyone that's looking to design a gasket a better feel of the corners and how we get that part done. So I'll just again start the screen share so we can continue the presentation, and we'll go through one by one. So I believe we have, do we have a, so there are questions being asked. Sean, thank you. You're answering questions. Thank you, sir. Appreciate it. Okay. So film splicing or infrared heat source splicing. This is it's better on sponge rubber. There's two different types of rubber, right? We have the solid rubber or sponge rubber. If you want to use conventional methods of hot splicing with sponge rubber, it's very hard. Chances are you will burn the sponge, you'll burn the actual profile. So we have to find a different way of bonding these gaskets together. So this is one of the equipments that we have is, it's an infrared splicing machine. Again, we have to design a specific tool depending on what the profile that we have. And the profile gets clamped onto the tooling. As you can see, these are the lights. These are the infrared lights that you'll see that come on. It heats the film, so it's spliced by using a very thin polyethylene film, and it heats the edges of the profile, or the actual outside edge of the profile. It gets put together with pressure and heat, and within seconds, your corner is bonded together. Okay. Advantages here, again, great way of bonding sponge, and it requires less, let's say, tinkering, or once the splice is done, it's done. There's less trimming involved or less or after work done in terms of compared to cold bonding or even vulcanizing, because of the film. The film is actually really quickly, once it's spliced, it's spliced. We rip the outer edges off. It comes all in one piece, and we go on to the next corner. So great resource for sponge profiles regarding that. Vulcanization. So this is using uncured rubber, putting it, again, we're clamped, as you can see here in the picture, we're clamping these onto the die. The uncured piece of rubber goes in the middle of the profile. Heat and pressure come together. It takes a bit longer compared to the infrared machine that you see to splice. However, the splicing here, or the vulcanizing, is a very strong bond to that. Great to use when it comes to low volume production, and it does not require, let's say, as much of a straight cut because of the uncured rubber that gets put in between the two, or the 45-degree angle, or even if you do a butt splice as they call it, it's more forgiving in terms of your cuts, so that compared to the infrared splicing machine. Okay, just to go back over here, this machine, great for if you have, say, a semi-rigid or plastic and EPDM compounds. You cannot use silicone or with this, or neoprene. It's EPDM or plastic that you can use this machine with. Now, this one here, we open the doors to more types of compounds. You can get silicone, we can do nitrile, you can do neoprene, you can do EPDM when it comes to this one over here, or this form of vulcanizing. So far, so good. We'll move on. Cold bonding. Basically, it's taking glue, as you can see up here, taking some glue, painting the edges, gluing together, and away you go. You got a seal. It's the advantages and disadvantages. So it all depends on your application. So we'll talk about that after, and I'll kind of cycle back through the slides to kind of showcase the different forms and which application, or how why this application, taking the application into consideration, why is it important when it comes to deciding how am I going to bond my gaskets together. Okay, so this is used, yes, typically used with low volume quantities. Advantages here is that if we have 10, 15 production workers in our production facility at one time, and we can get 15 people to work on cold bonding, because there's no machines required. It's human labor to do this. But this is a pure art form. Okay, this is and I can attest to it. I'm not allowed to go downstairs in production and actually glue these things together, because I tend to glue my fingers together when it comes to this. So it's a true art form when it comes to this, and I tip my hat to the people that actually do this, because the patience required to do it is tremendous. But like I said, it's more flexible than using machinery, because it's pure human labor to do this. Okay. Last thing that we have here is molding, or C-press injection. Great way to create radius corners. So a lot of designs that we come across, depending on the door application or window or whatever the case is, even hatch seals, for example, they tend to design with a rounded corner. It's very hard to bend certain profiles. They're limited in the radius that it can be bent. So if the radius is extremely tight, but you require a gasket to go over it, the only way to do it is to use a molded corner like that. Again, we can use, it could be rounded, it could even be on a 45 or a different shape. So that's the advantage of using a molded press. Disadvantages or things to take into consideration: you need a mold, and the molds are not cheap to provide. I've seen molds anywhere from, let's say, $3,000 Canadian. We've had molds that had gone up to even $25,000 Canadian on these. And the reason why is all depends on the complexity of the profile and what is required to mold on there. So remember what I was saying before, take the application into consideration, and that'll determine what type of splicing method I need. This is the toughest. So if you're going to be, if this is in an area, so as you can see here, it says high cycle time. So if this is in an area that there's a constant opening and closing of whatever the application is, and you have a volume, which again, very important, you have volume because of the tooling charges required, molding is the best way to go. Okay, or if you're stuck, you design with a radius corner and you cannot turn around and go back, and depending on the profile that's needed, you might be stuck going this route as well. But if you're designing from advance and you're designing if you're proactive in your design, you're thinking, taking things into consideration before determining what to go with, take that into consideration. High cycle times, and if you have volume, chances are the best way to go is with a molded corner. I'll put vulcanization and hot splicing, I'll put them in the same category, okay? This, if the bond between the corners, on the corners on these two forms is similar, very strong bond on there. So again, if you don't require a radius corner, but you might need, there's some cycle time, or even if it's a heavy cycle time, it's still recommended. You can still go with hot splicing or film splicing. There's still tooling involved because there is unless we use a profile that we have in stock or we've used in the past that we have a tooling for. If it's a custom made profile, we need to design a tooling to go and clamp over that profile to get the best possible pressure on when splicing the profile together. Now, again, take into consideration cycle times and do you need large volumes? Not necessarily. A splicing tool, I believe, is about $1,200 Canadian, depending on what on it could be range between, let's say, 1,200 and 2,000. So it's not as high as a molding tool on that. Okay, so do you need large volumes? Not necessarily. It all depends on what the application is and where it's going. Okay. The last one is the cold bonding. So if you're going to come to us and say, hey, I just need a gasket, it's being put between two pieces of metal or depending on the application and it's not moving after that, we can go with a cold bonding corner because there's no constant usage or rebounding, or maybe the cycle time is extremely low. It's being opened and closed once every 6 months. Yeah, you can go with a cold bonded corner. There's no need to pay for tooling, no need for that extra expense for that. The only disadvantage is what's the environment? So in the previous webinar, we spoke about the environment of where your gasket is going. If this is being in constant contact with water, it's not the best way to go with cold bonding. The water will react with the glue that we use and mostly everyone uses in the industry, and it could crystallize the glue, causing the gasket and the corners to spread open and potentially causing a leak in your gasket. So again, environment, very important to part of taking into consideration of where it's being used with that. So far, hopefully everything is good. Hopefully I'm making sense. So we'll continue moving forward. Lamination fabrication services. This is a pretty cool thing that we're into is, and no, we're not the only ones. We can custom make insulation. So depending on the application and what you require, in terms of thicknesses, in terms of environment that it's going into, is it being in contact with oils or gas? Do you need thermal and acoustic insulation to be taken into consideration as well? So the great part about this is that we'll custom laminate sheets from scratch. We'll take different components, we'll laminate them together, and then we'll use our WATERJET cutting services to cut out different shapes so that the customer gets the final part. So again, advantages here is that we can go beyond the standard parts that you find in the market, and we can custom make it to what the needs of the customers are. One of the examples here, what says thermal and acoustic insulation, we had a customer that says, we want to be able to keep the noise inside a compartment. However, there's a high heat source of where this compartment is. So we have to take that into consideration. So we have to figure out, is it low or a high frequency sound? And we were able to determine that it's a bit of both. So we had to take that into consideration when we were coming up with this sandwich, as we call it internally. So we had to have on the top layer something that will keep the heat in. So we have to use a silicone facing. We had to consider a polyester foam for the high frequency sound. We had to use a PVC loaded barrier for the low frequency sound. And then we used, again, another silicone foam, again, to keep the heat within the compartment. That does not exist in the market. So we had to come up from that from scratch, but we were able to laminate these together and then at the same time cut the pieces out so that depending on where it was going in that compartment. So this is what we learned today. So we learned that there's, we can custom fabricate different shapes, forms of gaskets, different forms of cutting, different forms of splicing, and what to take into consideration when splicing. Again, your environment, what's going on, what's going on around it, and the lamination of that. So, like I said, today was a pretty quick webinar. It wasn't going to be a long one, but if there's any questions, I'll stop the presentation over here and get back on. So if there's any questions, please go ahead. It is opened to discussions for anyone. Sean, is there something that you wanted to add to this while people are thinking of their questions?
I think just one thing I did want to mention was about kitting. Obviously, with the environment that we're in currently right now, that kitting is a big thing coming back to work. Less touches. We're able to take, like for instance, one of my clients is a boat manufacturer, and we kit the entire acoustical paneling for the inside of the cab for their boats. They reduced down their production time by about 4 days. It used to take about 3 or 4 people to do it. One was cutting, 2 were putting it in. It comes in one box. It's about 15 pieces. Each piece is labeled on top of each other. So one piece goes in, number 1 goes in, number 2 goes in, number 3 goes in. They're down to about 2 days with one guy doing it. Less people touching, obviously less people in a boat for social distancing. There's a lot of advantages to that. And that's one of the big things that we've been able to do. Quite a few of our customers do that now. And I think it's going to become a bigger thing going forward, just to reduce the amount of people, space, and touches.
Very good. Thanks, Sean.
You're welcome.
I'll use an example of an application regarding the different ways of splicing and what we determined. A customer approached us. It was actually a Tesla that had approached us for their supercharging stations. As they were building their network, what they noticed is that where the battery's being housed, there's an enclosure, and the gasket was always failing in there. And the type of gasket they were using was a sponge profile, which is fine, and but it's how it was being fabricated that was not. So there's a lot of failing points, especially in the corners of that gasket. So again, taking that example into consideration, because it's out in the open, it's out in the environment, the chance of being in contact with water was high. So we cannot go with a cold bonded gasket. So that specific gasket, what we use, it's because it's a sponge profile, we use infrared splicing on that. So there is volume, but again, take into consideration where it's being used and the environment that's being in. To use a cold bond is not recommended at that point. Any questions from anybody?
So we've talked about the time benefit when using the WaterJet, for example.
Yep.
With regards to the hardware, so to speak, for be it the film splice or the butt joint versus the injection molds, is there a big difference in lead time between ordering either the one or the two?
Absolutely, that's a good question, Sten. So when it comes to, for example, the injection molding or the molded corners, the lead time comes on the design aspect of the tooling. So the more complex that profile is, or what is required. So the tooling that I said before, that $25,000 tooling that we did, It took almost 3 months of design, of going back and forth with the tool and die maker, going back and forth with the customer. They had to change a bit of their design. So it was a lot of back and forth. So just the development of the tool takes quite a while. Then if you're looking at pumping pieces out or producing pieces, yes, it takes a bit longer than the infrared or the hot splicing to do. Just to think of it, it's a C press, so the raw material has to get injected into the mold, heat again, pressure to cook, so that takes much longer. And depending again the thickness, there's a lot of variable, but it is a bit longer than the other two processes. But the long point, or the long part in corner molding, is the tooling design, depending again how intricate that you have to get. Any other questions? No? I want to thank everyone, and please don't forget, if you're interested in this, we're doing our next one is next Wednesday. It's on gasket installation, or the best practices of installing a gasket. So keep that in mind. We'll be promoting that and posting that on our LinkedIn and on our social media. If you have any other questions, information is out there. Thank you, Paul. Paul, just a little quick chat. Thank you. But if you have anything else, please don't be shy to reach out to us. This is what we're here for. We're here to help out and spread the knowledge of how to properly design or take into consideration gasket design for your applications. Most of the time, I would say, let's say 8 out of 10, we're probably the last thought of component on a design, which is absolutely normal. But if we're trying to change that, we're trying to change that mentality to see if we can become at least part of the first, so that it's smooth sailing when coming to gasket design and fabrication for your application. So with that, I leave you guys. Have a very good rest of the day, and hopefully see you guys next week. Have a good one.